All right, well, welcome to the second Grow Farmer Forum meeting. We're doing harvest setup for the colorblind with harvest weed seed control. So I'm Michael Flessner. I'm one of the Grow team leaders. I'm real excited to have not only some Australian farmers, but some combine experts from really around the world here to help us in the States and get ready for harvest weed seed control and get us set up for it. So we're asking the combine to do something it wasn't necessarily designed to do, right? Not only separate and clean the grain, but also separate the weed seeds and deliver it to the harvest weed seed control, whether that be the Redicop seed control unit, the IHSD, a chaff lining chute, or whatever it is. So obviously combine setup is critically important for that, as well as dollars in your pocket to minimize the grain loss there. So but really, for us, it's if we're going to test harvest weed seed control in the U.S., it's really important to get this combine set up right. So I'm really thankful for all the experts we have on the call to help us get off on the right foot here. A couple housekeeping notes here. Audio quality can be a challenge sometimes with Zoom, and we have some really good, fantastic accents on the call. So to help everyone understand each other, just please try to speak clearly and slowly. Also, terminology can change quite a bit from region to region. So what we in the US call a combine, our Aussie friends call a header, and what we call a header in the US, the Aussies call a front. So if anything's unclear, please keep that in the back of your mind, or speak up or use the comment. We'll try to make sure that we're clear so we all know exactly what we're talking about there. Also, if you're not speaking, if you could please keep your microphone muted to minimize the background noise. So with that, I'll turn it over to Peter Broley with Primary Sales Australia.
Great, thanks, Michael. Thanks everyone for participating today. Just a sort of a little reminder of why we're actually here. The aim here is to start a conversation around how to better set up your harvester combine in your conditions, in your crops, recognizing that this very much varies according to what you're facing. And I do really want to emphasize this is the start of a conversation. We're here for about an hour, which means the likelihood is we're probably going to close up conversations early, so it will allow us to identify some things we want to do some further conversations into. I want to do a bit of an introduction to some of the people we've got here. So just want to thank also who we've got here. So from Australia, we've got Cam Taylor, who's I'm going to introduce himself in a sec. Peter Glover, who's also another grower in South Australia. We have Marcel Cringe, who is over there in North America for Bushel Plus. I've got standing to the left of me, or I guess what might look at the right, is Brett Asper. He's a harvester setup expert. He actually also works for one of the mill companies as well. And Cassie Van Vesthausen, who is a harvester expert, and he's got 10, 15 plus years working with the John Deere and IHS, the Case New Holland brands. What I thought we'd do right up front is go straight to get Cam and Peter to give us a bit of a explanation of what they've been doing in harvest weed seed control, some of the challenges they've faced, and give us a bit of a background of their crops and what they've done to deal with those, recognizing that really up front that some of the things you're facing in North America are very different. You've got some crops such as corn that we don't do or do very, very little of here. So please bear that in mind, and we'll do our best to see if we can have a good chat about it. So I might ask you, Cam, to give us a bit of intro. Who are you? What you've been doing? Where are you farming?
Hi, everyone. So I farm with my family here in southeastern Australia, in Victoria, in a region called the Wimmera. We grow crops such as wheat, barley, lentils, faba beans, and canola. So a little bit different to the crops that most of you are growing. Our soils allow us to grow a wide variety of crops, but we're purely rain-fed crops. So mostly winter rainfall, drying into the summer. and get some pretty hot harvesting conditions and some good drying conditions in the summertime. So so we farm about 12,000 acres now, and have two Case IH 7240 combines, or harvesters as we call them. Our harvest weed seed management program probably started off. Oh, sorry, I'll go back. We've gone through a rapid phase of expansion within our business, taking on a lot more acres or hectares. And through that process, we've sort of changed headers every 3 years, always been with a Case machine. And yeah, I've learned a fair bit along the way. So we started off doing a lot of narrow windrow burning. So if everyone knows what that is, it's just letting everything fall out the back of the header in a very tight windrow that we come back in the autumn time and burn all the material that comes out the back of the header. That's where we started. Then we went to chaff lining before the seed destructors probably became a little bit more popular, and they became an integrated destructor. And as soon as it became an integrated destructor that was belt driven on the back of the harvesters, so the Harrington seed destructor, we went that way and put them on the back of our 7240 headers models. So that's where we're at the moment. We've ran them for 3 years now. So we've had a range of different experiences over those 3 years and have learned quite a bit about them. Pete, would you like me to go into that now, or?
Yeah, could you just give us a bit of a taste of some of the challenges you faced and what you actually did, Cam?
Yeah. So the first year, it was really a really trial and see how they operated, and we were quite nervous about running them with the 7 series headers. Running out of horsepower was probably our major concern there. We started with the 9 series header, went to an 8 series, and then we got 2 headers and we went to a 7 series because we weren't horsepower limited. And then at a last minute decision, we put the destructors on the 7 series, and we've probably been harvesting 8-ton wheat crops, a bit over 8-ton barley crops, and then 3.5-4-ton lentil crops is what we harvest up to, probably. Well, yeah, up to 5-ton lentil crops in some spots, but canola 4 and faba beans up to 8. So that's the workout they're getting. We're running our harvesters at 100% all the time, and probably trying to push them even harder than that to get harvest done in a timely fashion, which isn't probably ideal. But yeah, we're doing that within the losses that we deem appropriate. But the first year, it was like one of the best seasons that we've had, nicest harvest conditions that we've had, nice dry conditions, little amount of dews, where it was perfect conditions. And one header had a problem, the other header worked fine, and we couldn't work out what that was. It was like just head scratching. Anyway, we searched and searched and searched, and we finally found that the delivery of the machine wasn't quite right. They'd missed at the back of the rotor, they missed a plate, and that plate was allowing all the material to fall onto the sieves, and all that material was going through the destructors, and then that was slowing down that machine. So as soon as we found that plate was missing, we put that in and it fixed that problem. But where we ran into trouble in that first year was in our lentil crops. we have green stems. So anything with a green stem, anything with dew on it, or really sappy, we really struggled to separate that in the machine. And then it was coming down into the destructors and gumming up the destructors and slowing down the capacity of the machine as well. So that's probably, so we just went back to a narrow windrow burn after that. We just dropped it into a line because our harvest speed got down to less than 2 kilometers an hour. So it was just unproductive. So we went back to narrow windrow burning in that instance.
Were you bypassed the mills in that sense?
Yeah, so that's exactly what we did. We put the chute over the auger in the back of the cross auger in the back of the mills. So the rubber flap that comes over the cross auger, and we just laid that material in that line out the back of the header. So that worked quite well. And you can just disengage the spinners, lift them out of the way, and all that material sits there as well. So that's how we go back to narrow windrow burning. It's not perfect, but it's a good compromise, I guess. Mm-hmm. So then the second year, it was okay. We probably had another pretty good season. We had some waterlogged areas and those types of things where we had some probably less yielding crop, which we could zoom along a bit quicker. But that was just utilizing the machine in the lower yielding areas. And then the third season last year we had frost, and that was probably another learning curve for us with how the machines work in frosted crops, and that doesn't work very well either. So we're back down to about 1 kilometre an hour, and that was not good. So we had to go back to narrow windrow burning as well.
So you bypassed again to deal with that issue.
Yeah, we bypassed again. So frosted crops, green crops, green weeds, they're probably things that slow the machine down, the capacity of the machine that we've found. But yeah, we're trying to take a lot of biomass. So we're trying to cut very, very close to the ground to capture all the weed seeds as well. So that's the one critical thing that we're trying to do, is get everything in the front, or what did you guys call it? The header, I think. So we're trying to get everything into the front of the machine. So we've got macked on flexi fronts that follow the ground. We run those pretty much on the ground all the time, trying to gather all the weed seeds in the front to then get it in the header. And then we're trying to separate that, obviously. And I think with the case machines, our biggest losses are our rotor losses. So anything that's staying in the rotor comes out through the spinners. And that's that's the biggest area that we're concentrating on, trying to get that rotor separation in the machines, and trying spiked ras bars, trying centering the rotor, and been mucking around a fair bit with that. Not much success as of yet, but that's where we're at.
We might come back to that particular challenge, and then we'll have a look at that. What weeds have you had you're mainly challenged with?
So our biggest weed that we're probably trying to chase is ryegrass. Is that a common? What would that be compared to, Pete, over there?
Michael, what would we look at as equivalent for ryegrass for you?
Yes, your Lolium rigidum. We have Lolium multiflorum, so basically another species of ryegrass. Mm-hmm.
Yeah. So that's probably our biggest, most prolific weed that we've been chasing for a long time, and really suits this type of machine. to gather at the end of the year. We're also trying to get any other weed that we've got in the paddock as well. So such as brome grass, such as canary grass or phalaris, and then if we have broadleaf weeds such as milk thistle, or marshmallow or mallow. So they're the types of weeds that we're trying to capture. The one thing that we're trying to do is capture those weed seeds before they fall on the ground. So we need to get them in the header before they fall on the ground.
Yeah, but Cam, just a question on that. I'm going to push a little bit because I want to get to P. But are you doing measurement of your losses? You talked about acceptable losses. Do you measure?
Yeah, so we've been doing some measuring. So what we're trying to get is less than 1% losses, grain harvester losses. That's the aim. We've been throwing out trays, doing trays, and seeing what comes out the header, especially out the rotor. That's the easy one to measure for us. What we've found is it's quite hard to measure your losses when you've got the destructors going. Obviously, you can't measure what's been destructed. And if you disengage the destructors, you change the airflow of the machine. So yeah, at the same settings, you change the airflow of the machines. What we've found is if you disengage the destructors, you get more losses based on your sensors in the machine. So we're sort of been trying to manage that, and how we've been trying to do that is you sort of disengage your destructors, set up your machine, so that gives you your standard, put the destructors back on, and then change your settings based on the yield is probably how we've done that a fair bit. So as long as we're not a massive loss in yield and we can keep getting a better sample, but you have to start from the base of what you know and then move from there, I guess.
Okay, so it sounds like you're setting a benchmark of what it is, and then running your mills to actually then go, okay, I've got a benchmark, I know where I've got losses through rotor or sieve, and then making a call based on what's happening, so you know where your losses are. Would that be correct?
Yeah.
Okay. Thanks.
Yeah, but as soon as we put those mills on, our sample will change as well, Pete. So it's a very it's a balancing act in that.
Yep.
So it would be fantastic to we probably need to do a stall of the machine and just get inside and have a look of what's sitting where. And we probably haven't done that. We probably just need to do the stalls more often to see what's sitting in the machine. So get in there after and assess what's going on. Okay.
Look, I appreciate that, Cam. Look, I might throw it to Peter Glover. Peter, can you give us a bit of an intro? Tell us what you've been up to, what you're running, and some of your challenges. That would be great to hear what you're facing.
Yep, no worries. And it's morning here, so good morning to us. Before I start, Michael, maybe what's the audience that we're talking to? Are we all combine operators, or just to work out where we're going to pitch what we're saying?
You got a mix there, Pete, from people who are running farms and running research, and others but they're all generally running machines themselves. So you got that. That's the mix you got there. You have people who are support to it, but generally they're running and having to do stuff with machines.
Yeah. So thanks for that. We farm in Eyre Peninsula, South Australia, which, as I said, for anyone who was there before, it's in the middle at the bottom of Australia. Most people's Australian geography isn't too flash, and but that's roughly where we are, and it's a similar area, similar crop types, similar weather patterns to what Cam's been just talking about. We don't grow those lofty yields that they do in the Wimmera, and most of you in the States or Canada, wherever you are, probably need a conversion, but 8 tonne a hectare of wheat is something like 300 bushels, just roughly. So it's I think that's a pretty impressive crop, and tests everything. We're a family farming operation. We're cropping about 20,000 acres, bit over, and we're running 4 deer combines currently, S790s. Hopefully an X9 is going to be in the mix this year. And for the last 3 years, we've had Redicop seed destructors on those, or the John Deere SCU. It's I think 2 of them are John Deeres and 2 of them are Redicops, but they're the same thing. We also, as a side, most farmers seem to do something on the side just to fill in their idle hours, and so we run a MacDon dealership on the side. So Cam, if you need any parts, we keep more parts than MacDon does in Australia, because we're farmers as well and understand that when things are working, you need them to keep working, and most machinery companies don't quite yet understand that. Anyway,
we buy a windrower off you, Pete, please.
Well, no, you can't, because MacDon can't build them. But apart from that, yes, yeah, that's another story. So yeah, we've ran virtually exactly. I don't have anything very much to add to what Cam's just said. Only slightly different experiences. We've done narrow windrow burning, which inevitably turns into complete paddock burning, and so that's a major issue for us, is to keep that narrow windrow burning in the narrow windrows. And anybody who's ever done it, the tests it, I think, and can't stop it quick enough. And so the seed control units or seed destructors are just the next tool in ryegrass. Again, is our major weed seed, but all the ones Cam mentioned, marshmallow is probably the one we spend the most money on just at the moment. Depending on crop types, the weeds that bother us tend to change from season to season. And the seed destructors, whatever your generic term is for those, they're just one more tool in that game, and they're certainly a less than perfect tool, but they're just one more part of the puzzle that goes on the end. And I think they fit in the burning area, and they're much more palatable. The job's done when you drive out of the field. And the issue, as Cam said, the seed destructors do a great job, I think. Most units claim somewhere in the high 90% of seeds destructed that actually go through the mills, but you've got to get the seeds in the mills. And so again, for combine operators, people who've run combines for a lot of years, they'll do a fantastic job of harvesting grain, but you never want them to just harvest grain. They're either picking straw up off the ground, they're thrashing green stuff out of ripe stuff, or now this latest thing, we're trying to put everything through them so we can get the weed seeds in them. And so then the combine engineers who design them to separate grain from chaff, all of a sudden we're trying to get them to do something completely different, and which upsets it. And so our guess is that it uses something like 10 gallons. Now what's that going to be? I was doing the conversion for you, but I've just stuffed up. So about 10 gallons an hour of extra diesel that goes through. And Cam spoke about class 7 combines and whether you're limited by horsepower or not. And always, particularly with the latest generation of rotor machines, when they put more horsepower in them, and that gives them the capacity to just shove grain straight out through the rotor and straight out over the back. And we're thinking that the limiting horsepower of the seed destructors is not a bad thing. It forces you to slow down a bit and drive the machine more at like the capacity where it can work. But something like 10 gallons an hour, haven't done the conversion back to gallons an acre, which is the important thing, but they use a lot of diesel. The tank that used to last all day now sometimes won't last all day, and diesel used to be cheap, but it's not anymore. So that's a significant issue, but it's another cost. In the past, it's equated to roughly one ryegrass spray, the cost of putting it through an SCU. And now, with diesel prices being more expensive, that's more expensive as well. I've probably got two things to add to what Cam said. One, to just agree that again, back to combine operators, you start off on the first day, you throw trays out, you check losses, you do all that stuff, and after about the first half a day, you get sick of all that stuff, and you've just got fields to harvest, and you just get to and drive the machine, and you don't really care too much anymore. And that's a generic term, but with the SCU, you don't find grain on the ground because it's all pulverized, so that makes you feel a lot better about that sort of that part of the operation. But it is difficult to tell, and the issue with doing a stall stop is that again, the SCU clogs up the back end of the combine, and it's very easy when you do a stall stop, either planned or unplanned, which are the more common sort of stall stops that we tend to do. It's very easy to get a lump of straw or green stuff or something, plug the opening into the SCU, and next minute you're doing an unplanned clean out of the combine. And so that's certainly an issue, and there's a lot of horror stories with that. We haven't had too many issues, but there's a lot of bad stories around. And the second area that I want to go in, we're running the Ready Cops, and every year there's a different version of the mills, and I'm sure everyone else is doing the same, but better hardening treatments and better design so that they tend to wear better. But we had 2 years ago where we turned the mills about halfway through, and they'd worn further than they should have. And so when we spun them the opposite direction, after about a half an hour, one of the mills that I was actually driving disintegrated, and it threw bits about 100 yards out the back of the combine and lit fires all the way where it went. And again, back to combine operators, over the years you'll know that we've added various things on. Grain loss monitors have been added. We ran straw storms for a while, which was a Canadian invention. Everything we add onto a combine just stuffs it up in some way and makes it harder to use, and these are no exception to that rule, and it causes plenty of other problems, and fires has been one of them. Bearing wear issues, mill wear issues, and it makes it more difficult to set the combine up, particularly that airflow issue that Cam spoke about.
Pete, just on that airflow issue, what sort of have you done to try and ensure you're getting your wheat seeds into your mills? What have you tried to approach?
Yeah, so the into the mill is easy. It's going through where you cut it off. Once it's cut off and into the combine, then it's pretty much going in there, unless we put everything through them, and so it's basically going in there once you get it in. But getting it in's the issue, because it's always the trade-off between harvesting capacity and doing the job of the SCU, and that's, you always, you can go another mile or two an hour faster if you just come up a bit and harvest quicker. And at the end of the day, most combines reap 5,000 acres a year, give or take, and you've got to get that job done whether you do it at 1 mile an hour or 5 mile an hour. And so again, your parameters change on the second or third week of harvest compared to where you start at the beginning.
Yeah. When you say getting it in, are you getting it in your front or keeping it in and not throwing out through the rotor?
Yeah, getting it in through the front. That's the main thing. Once it's in there, ryegrass seeds especially, they're almost for sure going to go through the seed destructor, and they do a good job after that.
Okay. You've mentioned some stuff there. I might throw to some questions in a second to give people a chance. So we've talked about some issues Cam faced. Sounds like you've had some similar issues around sieve loading and dealing with green matter crop. That challenge of making sure that we're able to pick up and get weeds into it and measuring to make sure we're making the most of that. I might throw to the audience there. Do you have any questions specifically to Pete or Cam? But it might be a good chance to talk. Just raise your hand or shout out loud. Turn your mic off. Okay, Wale.
Yeah, both. Peter, you talked about the fire danger. I'm in Montana and I'm kind of also in a very dry environment out here. So on the fire danger, do you guys shut things down when you're cutting in very, very low humidity because of the seed destructor?
Yeah, not because of the seed destructor specifically. I don't. It's maybe fractionally more dangerous for fires with an SCU on the back than without. But we have a harvesting code of practice that's a real thing for us on high fire danger index days where everybody shuts their harvesting operations down. And to this point, the SCUs make no difference to that, though they are more susceptible. They'll start fires more susceptible to mechanical issues and also potentially things like ironstone or granite. If you're in a hard stone area, you pick those up and they'll flick sparks out. But it's only the out of the ordinary issues that have been fire issues as far as we're concerned. Same for you, Cam?
Yes, so we've had a significant increase in the amount of fires that we have on our harvesters, especially in lentils, and we've even started to get them in canola. We're getting 1 or 2 a year in canola. Anything that makes a really fine powder with the destructors, and it really makes a big difference where the wind direction is coming from as well. So if anything is blowing up the back of your harvester or combine, blowing it back up the around the manifolds, around where the destructors are, and so we've really we've asked our local dealership to really streamline all the wiring looms on our left-hand side of our machine. If you're looking from the back, so as much material falls off there as possible, because that's where we're having some troubles coming off the exhaust. So embers catching on the exhaust and the really fine destructor material sitting on those looms. So we've cleaned that up a lot. That's helped a little bit. But then, yeah, where it gets stuck on top of your fuel tank and stuff like that as well. So you just have to be constantly blowing down. We'll when we're doing lentils, we're blowing down probably every 2 hours. If it's bad, more often, and to the point where we just stop harvesting and we'll just do it at night time.
Yeah,
so
there's a fair bit we could talk about fire suppression and minimisation, and if that's a conversation, I think we might just get Ben White also to come into a session, Michael, because he's got some strong experience there. Is there any other questions? Anyone got a question that they want to raise to Pete or to Cam?
Has anybody had any issues plugging when it comes to moisture?
You have, Brad, haven't you?
Yes. Yeah. Soybeans
wanna,
primarily.
What was your, Brad? Tell us what your situation is. What are you doing? Where are you? And what was your problem?
I'm in the United States, in Virginia, and corn, soybeans, wheat, and usually fall crop soybeans. When it's getting a little bit later in the afternoon, I'll have to stop the Rutacob unit, or I'll have to just stop the machine altogether because I'll start plugging when it comes to soybean stubble.
Right. Okay. And you're saying it's pretty moist conditions?
Yeah. I mean, it's not terrible conditions. I think it's just more or less with atmosphere conditions, more or less. What's going through the header, through the machine, and out the back, and she just can't keep up, I guess, is what I'm trying to say.
Okay. I think that may be a good opportunity to bring in Cassie and Brett on my to come and talk as well. So you're running an S680 with the Redicop SCU?
Yes, sir. Yep.
Yeah. Okay. Cassie, do you want to give us any comment? Because obviously we got this is a lovely green color machine. Any comments on where you've had plugging issues and what your thoughts are?
Yeah. Couple of points that Cam made about the frost damage. I've never worked with a control unit on frost, but obviously I've been in there with a harvester, and the harvester just works harder when it's frosted. So yeah, I would agree with that. When it comes to the
Cassie, can I get you to turn your video off? Your audio is really, really scratchy.
How's that, mate?
A little better.
All right. Yeah, so what I've said, I haven't seen the machines plug into crops that was frosted, but obviously I've been in there with harvesters, and yeah, the harvester just works a lot harder when it's frosted. So I can see how the control unit will be plugging when it's frost. What I've seen plugging, I haven't seen it in high, you know, when the humidity is too high. I haven't seen that. But I can understand the volume of the crops going into it, that it will be an issue with it. We've had customers here that was doing fiber bins, and it was fairly a large volume of material that went through it, and we didn't have it.
Lost you a bit there, Cass.
What's the go here?
That's right, you're back. Just repeat, it's fine.
Yeah, so I haven't seen any dramas with, you know, where the humidity is high, where it keeps on plugging. We do a lot of work in fiber bins here, where there's a lot of material go through the destructors on fiber bins, and I haven't seen any plugging there. I can put my hand up and say anything green. If it is green, you go around it. We've got customers here that will go out and spray Roundup over the crop before they harvest it, just to make sure that everything is died off. Yeah, if it is green, we go around the green patches and we come back.
I might just ask Brett to give any comments, because you were talking earlier, Brett, about what similar crop soybean would be for us over here, and recognizing different conditions. Where you've got this blocking occurring in John Deere, what were your thoughts?
Peter, you're muted.
Sorry, that's not only am I muted, but I'm not talking.
No, it's my end.
Sorry, the other Peter.
Yeah. Rolls. Go ahead. You're unmuted.
Are we? Oh,
Yep.
we're on. Sorry, guys. I also worked for a while on the Eyre Peninsula, so I've got a pretty fair understanding of where Peter is at. And you know, although I've never harvested soybeans, it's 20 years since I did a harvest in the United States, and my memory's a bit hazy because I'm an old fella now. The thing about plugging that we find on the entry into the mills south of us in our southern regions across here is largely to do with the volume of the material that's ending up on the sieve that we're trying to actually get to go through the mill. So we've been experimenting with all sorts of different things and across all the different coloured machines to try and maintain or improve rotor loss, but also reduce sieve loading. And I know it sounds counterintuitive, but what we end up finding is that we end up really basically over thrashing our material, and we end up with a really high sieve loading. And then that's what contributes to this. So last harvest, I did some experiments where we had guys with two machines. I'm saying two identical machines work side by side, both run a mill, neither of the type that you're talking about, but that's another story. And what we found was that everything that we did improved the machine that we did it to. So the pairs of machines that we're running, the guys that run them has told me straight away, this one is 30% better than the other machine, both in reduction of fuel burn, capacity, and mill wear and life. So to the extent that one of these pairs of machines, one of the machines he absolutely hates, and they smoked 4 sets of belts off the thing trying to get through harvest, and the other one they never touched. It just went like the wind. And the only difference is that we've changed some of the iron on the rotor.
So this, Cassie, you're so Cassie, you've talked about doing some of that on cereals with density packs with on the John Deeres. Would that work on soybean?
I don't think so. I think on soybean, it comes out of the pods easy enough. What we've done in the past is we've put the dense pack into something like lucerne, where it's really hard to get out of the pod. So I would keep away from the dense pack, keep it away from beans.
Okay, Marcel, you've got some pretty big experience too. Do you got any comment, particularly from your experience in dealing with crops in North America?
Yeah, hi all, Marcel here from Bushel Plus. I actually had a question to Brad, who asked us about the soybean plug-in. My first thought was, what do you find in the mill, in between the mill and the sieves? Like, what kind of material is actually plugging the mill? That would be my first question, to actually get a better context to the whole situation. That would help me.
I'm more or less finding just stems and stalks and pods of the beans. They just get wrapped up, and it just not enough space for it to go through the mill and the top end of the chaffer, and she just can't handle it. So I got to slow down a whole lot for her to get it through, or I got to stop and open up the back end of the machine and dig it out manually.
That's okay. That's kind of where my thought was going. What kind of, I mean, we're getting a bit technical, but that's where I kind of come in. What kind of concaves are you running? Like, are you running something like a round bar with a wide opening that lets a lot of stalk through when you have trying to push the combine for
round bar with a I think it's 3/4 of an inch to an inch opening.
Okay. And then when you go in a little tougher conditions, are you running those concaves a little tighter, maybe with a bit more rotor RPM as well?
I'm trying all kinds of things. It just kind of depends on the day. If I notice that she's starting to do that, I will try one thing different from one day.
Yeah.
But
okay.
Sometimes speed just has the biggest deal with it. I try to run in normal conditions. I try to run around 3.2, 3.3, but when it starts getting a little bit tough, I cut her back to around 2, 1.5 to 2.
Yeah, I mean, speed will certainly help you because the mill can then handle a lot more. No, not more, but the slower you drive, the easier the mill can handle the load, right? So,
Correct.
and the less material goes through, the slower you drive. But I think there's combine settings that you can do, as in different type of concaves and different rotor speeds, so that you're not producing as much, call it short straw, or as much broken stems that actually then fall through the concave and then plug the mill on the end. So that we want to just put the pods and call it the chaff and the small particles and the kernels through the concaves to the top sieve, and have the straw, the thicker stuff, going through the rotor to the separator grates all the way out of the back of the machine. I mean, it's easy for me to say this right now. I'm far away from your farm and your combine, but that's the theory that I'm going with. And it'd be interesting to talk further on these type of things, because that's the most important part of how to set it up in the front. Like in the front, in the beginning of the machine, I should say, with all this different terminology here. So in the rotor and, concave area, to make sure you get the right material onto the sieves, and then have the mill processing it properly. So that's where my brain is going at, that we get you a better sample on the sieves, because the mills can handle quite a bit. But if you feed a lot of stalks into it, and especially these soybeans, what's kind of your soybean yield in your area?
Average soybean yield can go anywhere from 40 bushel on up to 90 to 100 bushel.
Yeah, that is a lot of stalks. And for everybody who's never seen soybeans in the field, that can be like a little tree. Like that stalk can be tougher than canola out in the field. So there's things we can work on combine settings wise.
The closest thing that we would have that where we've had trouble with ours is green canola stems. So we've really found if we've got to open everything right up, let the canola dry down in a windrow. So we're swathing all our canola or windrowing our canola and then coming back. But yeah, where we've found some trouble is that green stalk in the canola. If that gets into the mills, it's a disaster. So we try and open everything up, just let it come through as open as possible. But yeah, it doesn't always work in all conditions as well. So it's pretty much pulling the pin when the conditions aren't right is where we get to.
Yeah, thanks, Cam. That's some good feedback there. If we got any other questions out there, or Cassie, you want to make a comment?
Yeah, Peter, I just want to add on to Marcel and Brad's issue there. This had nothing to do with the manufacturers, any of the manufacturers, but in the past we have extended the plate that's underneath the discharge beater. So the discharge beater floor, we have extended that plate, so to give it a bit of more of a boost for the material to jump up, because we've seen in the past where that material that goes through the rotors, and Marcel is 100% correct, with the material where we want it to be, what the sample is like on the sieves. So we want that material to come through the discharge beater just to shoot out straight at the back, because we have seen it where it comes through the beater, because of the weight of them, it just falls straight down to the back of the top chaffer, and that goes into our mills. So by just extending that floor plate of the discharge beater 6 or 8 inches, that helped us a little bit to get the material over the chaffer and away from the mills. It's just an add-on.
Yeah, so you're freeing up that space and help pushing it out.
Yeah.
Yeah. Okay.
So you're saying you took the you're saying you took the concave off the back of the discharge beater to not have that obstacle, so it should just go straight back versus having to go up?
Yeah, it's still flying up a bit, but we've extended that floor of it, so it's like a slide. It just gives you the angle of the material to go further up and away backwards instead of just falling straight down.
I think we're getting to some specifics, and I know that Marcel commented there's things we can talk further. I think we can come back to some of this. I know that Michael will want us to try and pick up on this. I'm going to ask Rodney to give us a bit of a question or a comment. Rodney, you've raised your hand, which is, I love that. I can see it.
I was simply going to comment. We have just finished with trying to do sunflowers with the Redicop. And the last gentleman that talked about extending that plate is a very intriguing idea, because exactly what he described was what we were having happen. The stalks, the sunflower stalks were real wet and heavy, and they would try to fall down onto the sieves instead of going over the top, causing our plugging. So I found his idea intriguing, to extend that plate and try to get a little more lift and loft on those stalks for the sunflower or the soybean gentleman. I just wanted to comment that makes a lot of sense from what we experienced with sunflower plugging with the Redicop. That's all I had.
Okay, great. I think the comment would be from any of the guys here would be, now it's important you try it. And if you're going to try it, one of the questions, and I'm sure Marcel will ask you this, is, are you doing any measures looking at where your wheat seeds are going? Do you measure your losses? Do you measure where your wheat seeds are landing? Are they going into your mill? Because Rodney, you're using what at the moment? You're using an SCU?
Yes, I'm a little bit with accent here, but I think you're asking, are we weighing?
No,
losses?
Are you measuring your wheat seeds where they go?
No, the researcher from A&M that I'm working with was measuring the amount coming out of the destructor, and the number of untouched seed is the only thing we have measured so far. Anything that was going through the mill itself, and then we caught samples to see how much was missing the mill.
Right.
But
And you when you say missing the mill, you took some samples what went through the rotor. Is that what you mean by that, Rodney?
yeah, we were catching. I think the way they had me do it is I'd walk kind of beside the machine with a box and catch in two different places.
As long as you stay safe. As long as you stay safe, that's the biggest thing.
Yeah, you have to stay behind it. I wouldn't let the researchers do it. I did it myself, because you got to walk at a fast enough pace to not be in the flow of that destructor, because it would be very dangerous.
Yeah. Well, there's a couple of solutions we can talk about too, but I want to emphasize that what Rodney just described is very, very important. Doesn't matter what combine you run, doesn't matter what mill you run, doesn't matter what harvest weed seed control thing you do. You want to make sure that you have a way of measuring or quantifying and checking if the weed seeds are actually going over your sieves into the mill or into your chaff line. Because if your combine is not set up properly and you're putting the weed seeds through the rotor and out the back through the chopper, then they're bypassing the mill, as Rodney was just describing, and then you're spreading all these weed seeds back in the field, and it's basically then you have the mill for nothing, and that needs to be measured to make sure that you actually see it, because it's tough to see this on the ground. The weed seeds are so tiny, and as you said, everything that goes through the mill is just powder. So you need to have a way of measuring that out, and in a safe and quick way.
So Rodney, just to comment on that. So we want you to try that plate out to see what it does. When you do anything, and I think Cassie maybe give a response, you need to measure at the same time to see that airflow, because Cam mentioned any change affects your airflow. Cassie, you got any comment on that?
Yeah, it is difficult to measure the way that we want to measure it, to see where it's going. The way that we measured it was just in the speed. We were doing 3K an hour. We've done some adjustments. Yep, we can do 3.5, 4K an hour. Make more adjustments. Yep, we can do 4.5K an hour. So that was our measurement with plugging of the mills. But I'll just show you here. I don't know whether you can see it really. I've got a little fish net here on a big long pole that I stick inside the header just to have a look at the seed that I can get out of it. That way you're still far enough away from the header, like myself said, do everything safely. We can't measure that because of our time frame that you're doing it. Every time that you catch the seed, the time frame is different, so you can't really measure it, but it gives you an idea of where the seed is going, whether it's coming out of the rotor or whether it's coming off the sieve. So it gives you a rough idea, and you can work with that.
Okay, thanks for that. Kenton, would you like to unmute and ask your question?
Yeah, and I apologize. It's kind of a simple question, but I've installed a unit on my machine, but we have yet to run it. So when everybody's talking about plugging it, Brad in particular, I'm curious, are we just plugging the top to where material's not going down in? Or are you putting enough material that belts are starting to slip? What are you referring to when you're talking about plugging up? What's happening?
For me, I had no more material going through the mill. The mill was still spinning, but it wasn't entering into the mill, and therefore I started seeing RPM loss, power loss, and of course you got to stop the machine, shut down everything, and open her up and dig it out.
This is Rodney. Ours was building up. The stalks were building up and to the point where it stopped up the beater that throws it out of the rotor. It literally plugged in, and we dug for a couple hours because it got so bound up. We didn't realize what was going on. So ours, it plugged up before the mill, and it was the stalks stopping it up, and it backed it up all the way into the beater, or the beater that kicks it out of the rotor is where ours stopped up.
Yeah, the back of that.
Okay, so I think I understand. It's not the mill itself that's plugging up. It's above the mill coming into it.
Mm-hmm.
Peter Glover, you got a comment? You've run the SCU for a little while. I know you're dealing with slightly different conditions, but any feedback for Kenton? You're muted, Pete.
Sorry. With green stuff and in the conditions that Brad was talking about of humidity, that can be an issue. Anecdotally, it's different between the brands. So the Terminator to the Harrington seed destructor to the Ready Cop, they're slightly different or slightly better in some conditions rather than others. And it's not been a major concern for us, but I'm certainly aware of it. As I said before, once you add anything on the back end of a combine, it just buggers up a perfectly good machine generally. And they're always working on getting that airflow issue better. The X9 coming, the SCU that's coming hopefully in a year or two with that's going to be a wider machine and a completely different type of airflow. So it'll be very interesting to see how that goes.
Thanks for that. Brad, you got another question?
Sure. Where I'm running the 680 with a Redicop unit, anybody who is running a Redicop unit, after installation, did they have to readjust their settings to get a cleaner sample in the grain tank after using their mill or anything like what I'm talking about?
What crop condition were you in there, Brad? What were you doing?
Primarily soybeans was the first crop that I started off with the Redicop unit. But then, after soybeans, we were not doing anything for a while. So it was just a learning curve. After I installed the unit, my sample wasn't as clean as it used to be. So I was just wondering if anybody else had any kind of issues like that.
Yeah, Pete, I can answer that. That is definitely the case. Yeah, mate. Because we suffer under the airflow in the machines, It's the same as when you've got just your normal chopper up in the air or down when it's chopping. One setting for one and one setting for the other. So when you've got your SCU on the back of it, you what Peter said, you change the airflow going through the machine. So you need to do your settings. You need to do resetting it because your sample will get dirtier. Because some of the air will get sucked through the SCU instead of doing its job what the air is supposed to do. It will just get sucked out quicker. So yeah, your sample will get dirtier, and you need to do some changes.
So just on that, I'll ask Brett to respond because he said exactly the same thing next to me. But you don't forget, you need to, Brad, you also need to measure because you're changing your airflow. You're changing your airflow. You're going to be changing where the wheat seed may go. It may end up, as you do that, as Cam said earlier, you may be now throwing more out of your rotor. So you've got to measure that to make sure that wheat seed then goes back into your SCU. And then look at what you change. But Brett, you want to make any comment? Because you almost said word for word. What was your thoughts on Brad's issue?
It's a common change that needs to be made whenever you go and do it. It's just that compromise thing, and you do have to have a bit of a play with it to try and get a feel for the way that the machine has changed. The key thing is remember that you're going to divide your crop flow with any mill or any harvest weed seed control method. You're going to keep your straw separated from your chaff. And so there's going to be other panels in there, and they all affect the way that everything breathes in the back of the machine. And that's what contributes to the blockage. So, look, and I think understanding what your rotor has a tendency to do. So, you know, the case rotor's got the individual little pegs on their rotor, and they don't have a tendency to roll the material. They have a tendency to agitate it. Whereas the base John Deere rotor is like an early case rotor. This is what we used to suffer in the early 90s, and has a tendency to roll the material. And as it does that, it doesn't leave a flat crop mat. And so the problem we have with our mill is that the material, if it's a bit green and a bit chewy, will come out like basketballs under the beater, and it just blocks the entry into the chopper, and then the whole thing haystacks back into the harvester or into the combine. So we've got to change the way that we think about that to get it to work. And generally, once we do that, we don't have that so much of a problem. But airflow is always going to be an issue. As soon as you go and put any other paneling in the back of the machine, you've changed the way it was designed. You've changed the way that you see it, and you change the way it escapes from the machine.
Okay, look, I appreciate we've been going about an hour now, and I did promise we'd do 60 minutes and be with that. There's a lot of things we haven't discussed today. The guys have talked about getting material into the front of the machine. We haven't talked about that. We have talked about the importance of airflow and the management through the machine, but there's specifics, as Marcel mentioned earlier. And there's a lot of little interesting questions you're raising about how we separate that straw and chaff and ensure we're getting those wheat seeds occurring to where we want them to go. I appreciate we're not going to answer lots of questions and solve the world's problems today. I know there's been some good questions also coming through the chat. My suggestion would be is send your questions back through to Michael. And we will try and then keep this conversation going, and happy to have another conversation again in terms of what's going on. But as we said earlier, if you hear stuff you're doing, try it, test it with actually measuring beforehand, and let us know how you go. Michael, back to you.
Yeah, so I've just put my email address and phone number if you guys want to call or text me with other things. And I really appreciate the discussion and the questions. I think something we need to do more of in the future. So a big thank you for everyone on the call, especially those getting up early in Australia. I think 6:30 local time for some of you or something thereabouts. And so, yeah, just want to say thanks, and we'll sign off here and be in touch.
Thanks, guys. Thanks, Pete and Cam, for being part of this.
Thanks, guys.